Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 5th, 2025, so just yesterday. This paper presents a new framework that can generate high-quality, controllable videos that are over a minute long, which has been a huge challenge for existing methods. The paper is titled LongVie, Multimodal-Guided Controllable Ultra-Long Video Generation, and as we'll see later, the results are really impressive. The authors tackle the core problems of temporal inconsistency and visual degradation that usually appear when trying to create such long video clips. So this first figure gives us a great overview of how their framework LongVie works. On the left, it shows the multimodal guidance. This combines dense signals, like depth maps that capture detailed structure, with sparse signals, like keypoints that provide high-level motion cues. The LongVie model then uses this guidance to generate video frames one after another. And as you can see in the results here, it produces these really consistent, high-quality video sequences across a bunch of different scenes, lasting up to a full minute. Alright, to really appreciate what the LongVie framework achieves, this figure highlights the core challenges it tackles. In the middle section, we see temporal inconsistency, where objects in the generated video can flicker or change unnaturally. Then, moving to the right, we see visual degradation. Over longer sequences, this can lead to issues like color drift and a general loss of detail, which are the key problems the authors set out to fix. So let's dig into what causes these problems, because this figure really breaks it down. The top section here looks at normalization strategies, which is a process of scaling data to a common range. You can see that when each clip is normalized on its own, you get jarring jumps. But with global normalization, where the whole video is considered at once, the result is much smoother. Then, the bottom section shows the impact of noise initialization. Using different random noise for each clip causes artifacts, while a single, unified noise pattern keeps everything stable. Okay, and this diagram shows us the complete LongVie framework in action. On the left, you can see how it applies that unified noise and global normalization to the dense and sparse inputs for each video clip. These signals, along with the last frame from the previous clip and a text prompt, are then fed into the core generator. This generator uses a special architecture called a DIT, or diffusion transformer, which starts with noise and refines it into the final, high-quality video clip on the right. Alright, moving to the results. This table lays out the quantitative comparison on the new LongVie general bench. And the takeaway is pretty clear. If you look at the bottom row for LongVie, it outperforms all the other models. It scores best in nearly every category, including SSIM, or Structural Similarity Index measure, which gauges reconstruction quality, and LPIPS, a perceptual metric where lower scores are better. The results show a clear advantage in both video quality and consistency. Okay, so to understand why their model works so well, the authors did what's called an ablation study, which is where they test each new component by turning it off to measure its impact. The top section here shows that removing global normalization or unified noise hurts the consistency scores. Building on that, the bottom section demonstrates that removing their degradation-aware training strategy causes the visual quality scores to drop. This really confirms that each new idea they introduced is making a significant contribution to the final results. So, in conclusion, the LongVie framework makes impressive strides in generating long, consistent videos by cleverly addressing core issues like temporal drift and quality loss. It's a really solid contribution to the field. That's it for this